How you doing? Mohammed Porgaz here with the last video for the concrete mixture design and proportioning, steps 6 to 10. You have probably already watched the videos prior to this, and you know that concrete mixture proportioning goes through 10 steps. And we have covered steps 1 through 5, and today we will cover the rest of it. And it turns out steps through 6 through 10 are pretty straightforward. And steps 6 through 8 are mainly accounting and bookkeeping, and they are very, very easy. Now, let's get started by step 6, determining the amount of cement. Alright, we have already calculated what is the water content. We have also at this point selected what is the water cement ratio. Now we can do very, very complicated computation to figure out what is the weight of the cement. And that very complicated computation is shown over here. We divide the water content to water cement ratio, and we figure out what is what the weight of the cement is. Now, in addition to this, at this step, you have to check whether there is a limitation on the minimum or maximum, for that matter, cement content. Now, of course, this table over here shows you the minimum cement content that is generally used for workability, finishability, and abrasion resistance. Sometimes owners or operators will specify the maximum maximum cement content as well. But this minimum cement content in this particular case really depends on the nominal maximum size of the aggregate that we have chosen previously. And you can see over here, for example, for maximum aggregate size of 1 inch or 25 millimeter, there is a minimum cement requirements, kilogram per cubic meter or pound per cubic yard of concrete. And you have to just check this. Now let's go back to our example, determining the amount of cement. And in this particular case, we said that our water to cement ratio turned out to be 0.424. We said that the water content of our mixture was 290 pounds per cubic yard of concrete, and then we can calculate the weight of the cement, and it turns out to be 648 pounds per cubic yard of cement that we need to put inside this concrete. That's it. Step 6 is over. Now we move to step 7. Step 7 is estimating the coarse aggregate. The amount of coarse aggregate that we want to put in our concrete. Now we will start that with this table that it looks very complicated, but it is very easy, and especially when I solve the example, you will see that this is particularly easy. On top over here, the fineness modulus of sand is given to you. Let me delete this line. And on the column on the left, 2 columns on the left, the maximum aggregate size in millimeter and in inches given to you. They are the same thing, just in 2 different units. And this table provides you with a coefficient. This coefficient practically tells you what volume fraction of the unit volume of concrete should be filled with coarse aggregate. And that is a very complicated description, but an example would be very, very easy to comprehend. In our particular example, again, we are on an example slide over here, the red ribbon. We said that the fineness modulus of our sand is 2.8. Maximum size of aggregates was 1.5 inch. So if we draw a line over here, we will see that this table gives us 0.71. This means that 71% of our 1 cubic yard should be filled with coarse aggregate. Okay, 1 cubic yard of concrete is 27 cubic foot. We multiply that by our factor that we got out of the table, the bulk volume, 0.71, and that gives us 19.17 cubic foot. Now, this is the amount, basically the volume of the coarse aggregate that we want to put. Now, we want to now calculate the weight because we do not want to measure the volume of the aggregate. We always want to measure the weight of the aggregate. That's a lot easier to do. We set that 19.17 cubic foot that came from right over here, and we multiply that by 100 dry rod unit weight of the concrete, and that will give us 1917 pounds. Now, in fact, this is the amount of aggregate, this is the weight of aggregate that this is the bulk volume, including the space between the aggregates. And in a second, you will see that we will use the absolute volume method to fill the entire volume with aggregate. But this is the weight of aggregate. However, this is not correct yet. We calculated the amount of coarse aggregate, the weight of coarse aggregate that needs to go inside the concrete. However, we calculated that based on dry rotted unit weight. Now, dry rotted unit weight is, of course, dry. The aggregate that needs to go inside the concrete has to be in SSD condition, so it does not have any transfer of moisture between the cement paste and aggregate and vice versa. Therefore, we have to correct for the absorption of the material. Now, for our coarse aggregate, the absorption at SSD condition is given in this table to us as a part of the basically information about the local material, step 1, that it is 0.7%. Therefore, we have to adjust the weight of the aggregate for this. We said that the 71% of the volume of 1 cubic yard, which is 27 cubic foot, needs to be filled with the coarse aggregate. We calculate the weight of that, but this is a dry weight. Therefore, now we have to account for the amount of moisture, for the mass of the water inside the aggregate in SSD condition as well. Of course, we have this oven dry weight, and we use this formula to calculate it from the aggregate lectures. You probably remember this, that you can calculate the weight of the SSD weight of the coarse aggregate, and over here we multiply this basically by 0.7%. We increase the amount of the aggregate that goes inside the mixture, because part of that is actually moisture that is moving with aggregate inside the system. And now we end up with 1930 pound of aggregate for our mixture. Now we move over here to step 8, which is determining the fine aggregate content. This is based on the so-called absolute volume method. This is very straightforward. At this point, we only do some sort of accounting, and we account for the volume of different component that goes inside the concrete. Now, we said that we have the weight of water, we divide that by the density of the water, and that will give us the volume of the water. Now, we have 1 cubic yard of concrete. We calculated the volume of the water over here that goes inside the concrete. Then we have the weight of the cement. We divide that by the density of the cement, and we calculate how much volume the cement will occupy in the system, and we add that to this 1 cubic yard. Then we have a coarse aggregate or gravel that we calculated the weight of that. We know the density of that, and we calculate the volume of this. We calculated the volume of that inside the mixture, and we calculated that. We also know we have 5.5% air for our exposure that we consider. Therefore, we multiply the 27 cubic foot by 5.5%, and that will tell us 1.48 cubic foot of that is air. The rest of this has to be filled with sand, and that is what we are doing. So basically, what we go ahead and we calculate all of these components. We sum up all the volumes, and we end up with 21.53. 27, which is 1 cubic yard, 27 cubic foot, minus this volume will give us the volume that we need to fill with sand. Now, we know the density of the sand over here for our local material from the table in our example, and by multiplying that by the volume of the material that we need to fill, we can calculate the weight of the sand that needs to go inside this mixture. All right. So this is really all there is to this, to the batch weight, and you can see that we calculated amount of water content, pound per cubic yard of concrete, cement, coarse aggregate, fine aggregate, and then, if, of course, air does not have any weight. We put just 5.5% for one cubic yard, and we can see that the total weight of the 1 cubic yard will end up this. Now, we did a lot of hard work, and we got to this. Where do we go from here? Step number 9, we're getting close. This step is adjustment for moisture. In this particular example that we solved, we saw that the absorption of both coarse and fine aggregate at SST conditions are equal to the moisture content of it. This in reality rarely happens, and moisture content of the aggregate in the plant, in the batching plant is generally different from the SST of the material, and therefore we have to account for that moisture difference. Now, we are not going to go through that step over here because that is not required for this particular example, but in class we will solve an example where the moisture content of the aggregate is different from the SST absorption of the aggregate for both coarse and fine aggregates. And in class we will learn how to do that moisture adjustment. It is practically very easy. We have to just add or subtract from the mixing water the amount of water that is lacking or extra that goes inside the mixture. For this particular example, we see that these for both coarse aggregate and fine aggregates are equal, and therefore we can skip this step and move on to step 10, which is conduct a trial batch. Of course, over here in this presentation, I will not be able to mix concrete for you and do adjustment. But the essence of this step is that all of these steps are suggestions. Everything that we covered is suggestions and as a suggested practice for mixture proportion. When we are making concrete material, we are making this material with a locally available material. And these are different from places to places. And therefore, you always have to conduct the trial batches to make sure that you are getting the expected performance from your mixture. And if needed, you have to adjust the mix proportion to be able to achieve the workability that you want, to achieve the strength that you want. And you can very often do this based on the experience. A lot of the ready-mix producers have a lot of experience in this and have a very good handle on the local material, and they use that expertise and their experience in proportion. This covers the 10 steps of mixture design and proportioning, concrete mixture design and proportioning, and I hope you learned one thing or another from this set of videos, and I will very soon see you for another lecture.